Hello everyone. Today we will be talking on behavioral modeling. This is part of our software engineering course where we were now discussing the analysis modeling of the requirement. The topics that we will cover today include what and why of the behavioral modeling, and then we will go into the three types of models, that is state diagram, sequence diagram, and collaboration diagram. So let's look at what behavioral modeling means. It indicates the response of the software to an external or internal events. Those events could be data conditions or input data or a signal coming into the system or any other stimuli that hits the system. And whenever it happens, the system will have some certain change in the behavior. That could be states, or it could be some kind of collaboration or some kind of actions. So to create such kind of models, we have to evaluate all the use cases. And when we evaluate the use cases, we have to understand what is the way and what is the sequence in which the interactions are happening within the system. And when we identify those, we will identify the events that are happening and how the states, what are the different states that the objects are taking, and how the events are affecting the transition of the states. And accordingly, we will build a state diagram for the system. Then we can create the sequences for each use case, how the control is flowing. And from that, we can create the sequence diagram to show the collaboration between the different classes and their instances. Then in a similar way, we can build the collaboration diagram. There's a little difference between the sequence diagram and the collaboration diagram, but both of them show the interactions. And then we can review the behavioral model, all these three models that we have created, to verify the accuracy or the consistency with the use case scenarios and any other requirement narratives that we have. Then we can complete our behavioral modeling. So we'll take a relook at the elements of the analysis model. Under the behavioral elements, we had stated state diagram and sequence diagram. We will also be considering collaboration diagram because in the later UML versions, the collaboration diagram is considered, and activity diagram, these are also considered as part of the behavioral view of the system. So under the behavioral diagrams, we have the interaction diagrams and we have the state diagram. The interaction diagrams are the dynamic nature, they denote the dynamic nature, how the objects are interacting under certain conditions or under certain events or under certain messages. So, and they collaborate to satisfy an objective or a particular user functionality. So under this interaction diagrams, we will be looking into sequence diagram as we had discussed it earlier, that depicts the message exchange between object instances and any external user environment in a time sequenced manner. And in collaboration diagram, we will show just the collaboration between the different objects to satisfy certain operations. And in the state diagram, we said that we will look into the events and the states of the objects and how they transition based either on a condition or an event. And similar to the use cases, we can not only use these three models for our design, but also they will help us in creating testing scenarios for the final software validation. So the first and foremost thing is to identify events and states. So when we read the use case depicts the activities that involve actors and the system. The use case description contains the sequence of activities or the dialogues between the system and the actor. So if you go to the use case, there is an actor and it is involved in a particular use case. It is associated with an use case. And when you go to the use case description, then we will get the sequence of activities or a kind of a dialogue that is going on between the actor and the system for performing the particular use case operation. An event will occur whenever the system and an actor will exchange this information. The event is actually not the information, but the fact that the information has been exchanged, that the fact that a particular information has been exchanged is an event. An actor should be identified for each event, and information that is exchanged should be noted, and the conditions and constants should be listed. So whenever an event happens, all these things we have to keep, we have to store it, we have to acknowledge it, or we have to keep it noted. And the state of the system or its relevant classes before and after the occurrence of the event is to be recognized and assigned a name or a identifier. So we have seen how events and states have been created or being identified. Then how to represent it? So once the state is there, we have to represent it, and there are two types of states. One is a passive state, the other is an active state. So when you can say passive state means this, there is no change. It is in the current status. Whatever is the object's attributes at that particular state remains. It doesn't change. So this can happen when system is either initiated or it goes to an idle condition. Some applications that are more of data processing type may be said to be in a passive state, as the events, the data events, they are not that much important for it. For example, another suppose there is a game software and there is a class which is called the player. So player is kind of an actor, so that is a class, and it will always be in a passive state. If the game is idle, that means the game is not being played, then it is in the passive state. And then it will only have the current position and the orientation. That will be kind of fixed. But when it comes, if when the game starts, then what will happen? The active state will start. Active state is the current state of the project as it undergoes a transformation or processing due to the occurrence of an event. So when the game is being played, what will happen? This player will go from, will be either doing some movement, so there will be a moving stage, or he will be in a trapped condition, or he'll be in an injured condition, or he'll be in lost condition. So these are the different, depending on the sequence of the events, these states may come. So it will change the state. So because it is changing the state, it is called an active state. An event must occur to force an object to make a transition from one active state to another. Unless the event comes, the objects will remain in a passive state. So now let us see how we will describe the state. To describe the set of properties and values describing the object in a well-defined instant are characterized by the name, the actions. The actions can be entry and the exit actions. Then the actions executed due to an event. So when the event is happening, then there will be some actions that is going on. Entry and exit are special events, which are the entry and exit actions, and there will be some activities going on inside the state. That means when the current state is alive, at that particular time the object will do some activities, and those are called do activities or actions or activities. And also these activities may support nesting. So within a state, another state will be formed because of these do activities. And some do keyword activates, they will activate the substate machine. So with the nesting will create a substate. Now we'll see state diagram for the analysis classes. So what it will have, UML state diagram that represent the active states for each class and event will that cause change between these active states. So for each active class, we can represent the state diagram, and it will show how these active states will change due to some event. They are also called as state transition chart because that state is transitioning, or it is called a state machine, or simply a state diagram. It depicts the sequence of states that an object will undergo throughout its life in response to the outside message or an event. And the state is the set of values that an object holds at a specific point of time. So these set of values that the object holds will identify the state, and that state will be given a name. Then the components of the state diagram are states, its events, that is the event that is causing the transition to the state, and any condition or the constraint related to that particular state, and the activities that are undergoing within that state. So how we will denote it? We will denote the state by a rounded box, and the rounded box can have some compartments. There will be a name compartment that will hold the name of the state, and if a state will not have a name, we can call it an anonymous state. Then the internal transition compartment will be there, that will hold the list of internal actions or activities that will be performed when that object continues to be in that state. So until and unless another event happens by which the state will transition, till that time these activities will continue to be performed. So those activities will be written inside the internal transition compartment. Then transitions are arrows. So to denote that transitions are happening, we will use arrows, and they will point from one state to another state. So these arrows will denote that a state can change. When this state can go to the state 2, and events or conditions that trigger the transitions are written beside the arrows. So against the arrows we will write the what are the conditions that have happened for which the transition occurred. Initial and final states will be indicated by circles as in the other diagrams such as the activity diagram. A system or a state diagram may have multiple final states, but there will be only one initial state. The multiple final states can happen because under different conditions, the object will go to different final states through following different paths. So this diagram is showing the notation of the states and the transitions that we just discussed in the previous slide. So this is the compartment, this is the rounded box denoting a state, and there are two compartments. This is the name of the state typing password, and these are the conditions. These are the activities that happen inside the state when it is in this state. So at the entry point it will set echo off, at the exit point it will set echo on, and otherwise it will get character and store character. So why it will do this? How it will come to this stage? It will come to this stage by a transition which is denoted by this arrow. And what is the event that is happening here? It is a request to display enter password. And this is the initial state which was in the idle state. This was a passive stage. So when this event happens, then it will transition to the typing password. So, and these are some other, working is another state, and here are some internal actions for it, activities, and that is what it is showing. So these are the event. Get char is an event, entry is an event, exit is an event. So on this event it will do this. Then we can see a little another state diagram. Earlier we had seen the notations. Now let's see the state diagram of an entry access system. So this is the system that is being built, and for that we are trying to create the state diagram. So there is a locked state, there is a reading state, there is a comparing state, and there is a selecting state. So initially it will always be because it's an access system, so it will always be in a locked stage. So only if some key is hit, then the transition will start. Otherwise it will be in the passive state. And when the key is hit, what will happen? At a pre-assigned time interval, it will read the password entered by hitting the keys. So this system will always keep reading whether somebody has has hit some key, and that will happen only when the timer is greater than the locked time. So there is a threshold lock time. If it is within it, it will continue to be here. So at certain intervals, it will go and keep reading it. When it reads something, then it will be the password that somebody has entered. So then it will come to the uh, comparing state. At a pre-designed it will read the password. In the comparing state, it does internal processing to check the validity of the password. So that is what it is being done here. If the number of tries get exceed, then it goes to the lockhead. So suppose it is not valid, then it will keep asking for the password. It will keep on reading the password. Otherwise, it will go to the locked state. If it is valid, then what will happen? Which will within the time limit, it will go to the selecting. And selecting, what it will do, it will be some menu to select something so that it can open or do some actions. Similarly, we can see a order management system. There is the idle condition, which is the passive condition. Then some object will some initial object time of the object. So what will happen? It receives a request for sending order. So when the request will come, so that is the event that will happen here. Then it will come to the send order intermediate stage. This is another state. This is one state. This is another state, and then it has to come to this state again, because a valid request. So it will check whether it is valid. If it is valid, then it will come to this state. Otherwise, it will go to the abnormal exit. It will give some message and go out. And when it comes to the valid service, it will ask for selection. So a selection menu will come, either a normal or a special order. So when the user has selected, so then it will come and it will ask for some confirmation. And once the confirmation has been reached, then it will dispatch the order. So in each of these arrows, there is some event that is happening or a message is coming, and only then that state transition is happening. So I think through this example, all of you must have understood what is a state diagram. So to summarize state chart diagram, it describes the behavioral aspect of the system objects when it is in execution. Activities in the state diagram show the activity of the object that actually performed in the operation. The aim of the state diagram is to provide understanding of the algorithm involved in performing the method. So when it is in a particular state, what is the operation it is doing, or what is the algorithm, what is the tasks it is doing. As such, the states of an object can be identified as the conditions of object at a point of time when a particular event occurs. So states of the object can be identified, and within the state, we know the action. So when there is an algorithm or a detailed flow of the control, then we have different states and different message or event coming in, and accordingly the operation can be properly defined. An operation occurs, an action occurs concurrently with the state transition, or as a sequence of it, generally involves one or more operation of the object. So whenever there is a sequence, means there are more than one operations. So it's a set of events are happening. Otherwise, it will happen within the state in a concurrent manner. To complete the object-oriented design, all the activities within the state diagram must be assigned to the objects, and all the control flows are associated to the links in the object diagram. So we have to convert the state diagram in the design phase by assigning it to different object methods and different object attributes. Now we come to the other diagram, which is called the sequence diagram. In the sequence diagram, once the classes are identified and events have been identified by examining the use case, the analyst can start creating the sequence diagram. It will represent how the events or the messages cause flow from one object to another object in a function of time. It is a different view of the use case diagram that represent the objects and key classes and the events that cause certain behavior to flow from one class to the other class. And this event flow or the message flow will help in creation of the effective design, because we are able to see how the objects are interacting based on the message flow. So let's look at some of the definitions. It shows the object interaction during their active life, called as the lifeline. So in the sequence diagram, a particular object will have an active life. Just like we said that active states and passive states. So here what we will have, when the object is interacting, sometimes it will have an idle life and sometimes it will have an active life. And this it is called a lifeline of the object. It indicates what and when messages are exchanged between the objects. So the sequence diagram will indicate to us, because we said it deals with the time sequence. So it will not only tell us what messages are being exchanged, it will also tell us when the messages are being exchanged between the objects. So there is one object and the other object, and it is exchanging the message. It consists of two dimensions. The vertical direction represents the dimension, that is from top to bottom, is a time dimension where we have defined our lifeline. And in the horizontal direction, it represents different objects and their interactions. And as the time progresses, time will always progress from top to bottom. And objects involved are listed from left to right. The objects involved are in the horizontal direction. So they are listed in the left to right in the same sequence that the messages will flow. Messages are sent in sequence from left to right between the objects. A sequence diagram is an alternative way to understand the overall flow of control in the software system. In the sequence diagram format, you can see this is the actor that we saw in our class diagram, and these are the three objects. You can see that there is a class, and from the class, this process order screen is one class. It is a boundary class. And then there is the item. This is another entity class, and it has been instantiated. So we have got this dot dot and the underline. And there is a stock item class. This is one object. So there are three objects which have been instantiated. And this is the use case for one process order. So this actor is doing the process order. So the process order screen is there. So initially these are all in the activation stage. So these are the lifelines. This is another lifeline. This is another life. So this actor is active, and this process order screen, this is active, and the item object is active, and the stock item is active. So this is active for a small time, this is active for the small time, and this is active for a longer time. This whole thing, this dashed line, is indicating the lifeline. And there is an item query equal to returns this solid lines. So when there is a message going, then it will be a solid line, and when the message will return back, it will be a dashed line. So that is what it is denoting. Returns are dashed lines and calls are solid lines. So from here there is a enter item number for order processing, and then it will when it enters this, then it will try to check whether it is a valid item or not. So it will check in the item class. So find a message is going there. So this is the sequence number 1, first message, and this is the sequence number 2, this is the second message. Then another third message will go, because it has to find out how much quantity of stock is available. So it will go there, and then it will return from here to here, from here to here, and finally it will display the results. And there will be another path which will be exceptional path. So exceptional return message may be added, not found, from the item. So if the item is not found, then there can be an exception here, not found, to the process order screen, or error from the process order screen to the sales. This is the sales actor, to the cells UI it can go. This shows the sequence diagram creation and the destruction. So when this activity, this object A of class A, and this is object B of class B. So this is sending a message. So some sequence diagram is getting created, and some operations. So this lifeline is getting created, and this object is getting instantiated because of this message. Then it is doing some operation. So this is like your new operator, and here some action is happening, some other activity is happening. So maybe some method is being invoked from this one. So this one is doing that operation, that method, and the result is coming out. And once the result is come out, this object is not required anymore. So it can be killed or it can be destroyed. So here the construction is there, and here shows the destruction of B. And so this one gives the message for destroy. This is another sequence diagram. The timings, it is showing the timings. Suppose the timings are delayed. If the timings are delayed, then we can give some, instead of straight lines, we can horizontal lines, we can give some slanted lines. So slanted lines show propagation delay of messages, useful for modeling real-time systems. So whenever you are expecting in your analysis or in the design, you are expecting that there could be delay, so you can give the slanted lines. This is another example, the hotel reservation, where these are the objects, a hotel chain, and within the hotel chain there is a hotel, and there is a interface entity or a object, that is a window. So this is the user interface. So there is some request has come, make reservation. So this is the message. So now this one gets instantiated. So the lifeline starts from here. Then this hotel chain object will send a message to the hotel, to particular hotel inside it, and it will keep checking for seek the availability. So once the availability has come, then it will make a reservation, and it will ask for a notice, confirmation notice, and that will come back to this person. So these are the activation bars. If a room is available, this is a note you can put there. If a room is available for each day of the stay, make a reservation and send a confirmation. So the return path is not given here. So actually it will only the onward path has been given, the solid line. The dashed lines which will return the message is not given in this example. Now we come to the third one, which is called the collaboration diagram. The collaboration diagram shows similar information to sequence diagram. Only thing is that except the vertical sequence, that is the ordering that it is giving, that will be missing. And in its place there will be something else, which are the object links, the solid lines between the objects that interact, like a network of objects it will show. On the links there will be some messages and arrows with one or more message names that show the direction and names of the messages sent between the objects. And the messages can be numbered. It is not mandatory, but if you really want to have the order also in the collaboration diagram, then you have to give the number to the message. The emphasis is on the static links, which is showing the collaboration. So here we are more interested in which are the objects which are collaborating. And whereas in the sequence diagram, we were more bothered about the sequence in which they interact. In the UML 2.0 onwards, this collaboration diagram is not given anymore, and in its place, what they write is the communication diagram. So these are some of the examples of the collaboration diagram. This is one object, this is another object, and this is another object. So this is a phone, and this is one user, and this is another user. So it shows how between the phone and the two users, how the interaction is happening. So there is a off hook, and there is the dial tone is there, and then there are some sub messages also, or subsequence. So it is off hook, then 1.1 is dial tone, then 2 is dial. So the dial is coming. So always it is showing an arrow. With the message, it is showing an arrow. Again, with the message, it is showing an arrow. So when the off hook is coming this side, dial tone is going that side. When the dial is coming this side, if the dial is correct, then the connect is going on the other side. And this is like the phone exchange. So and when this comes, then it has to connect it. So when the this is coming, the dial is coming, then it has to do the connection. Only when it does the connection, then it will do the connect. It will give the connect message. Otherwise, the dial will come, then it will first ring, and only when this person is taking the phone off the hook, then it will get connected, and therefore the connect message will come only after that. So here the understanding the sequence of the events is very difficult, or the sequence of the message is very difficult. But what we can see is that how the collaboration is happening, that we can see. And similarly here there is the elevator, door and light, and the cabin. So one, two, three messages are there. To go up, then turn on, and then close. So unified modeling language, both sequence diagram and collaboration diagram are used by the name interaction diagrams, that we stated in a previous slide also. That under interaction diagrams, there are two types of diagrams under UML. One is sequence, the other is collaboration. Both diagrams detail about the behavioral aspect of the system, the way the objects are interacting. The difference is that in one we give more importance to the collaboration, in the other one we are giving more importance to the time sequence. So we can actually give the difference between these two. Here the structural organization of the object is more important. Here the sequence of message is more important. So always we are trying to visualize the sequence of messages, and the time in which it has happened, the when is more important. But here the object structural organization is the main focus. And interactions of this, when we have an interaction of small number of objects, like in the example we have seen, then this is very meaningful. The collaboration diagram is very meaningful, because it is very simple, and it can depict us. We don't need to go into a very detailed sequence diagram. But whenever there are more number of objects, and a lot of messages and response back return messages are going, then we have to do the sequence diagram under the analysis, so that we can design it properly, and we can implement it as per the proper methods in the code. And this is the same example. This we wrote it in a collaboration diagram form: call, exchange, receiver, talk. And if we write the sequence diagram of it, it will look like this. So we will have these lifelines. These are the objects on the top. So we will have a horizontal and the vertical, and these are all the messages. Summarizing, we first discuss what is behavioral modeling and what are these constituent diagrams under the behavioral modeling. And we looked at into the way to create the state diagram. From the use case diagram, we discussed how the state diagram can be obtained by identifying the states, the events and the states, and it depicts the dynamic behavior of the system or its objects in response to certain events. Then we came to the sequence diagram, which is another behavioral diagram. It is actually called the interaction part, one of the interaction diagrams between objects when they are in action, when they are doing some work or doing some operations. We saw some examples to understand its components and their use. And then next we went to the collaboration diagram, which is an alternate to the sequence diagram, and we discussed some of the differences between that. And we also noted that the latest version of the UML has renamed the collaboration diagram as communication diagram. So we have come to the end of this lesson. Thank you very much for giving me a patient hearing.